This is Mr. Precella, and today I want to work two application problems where I use Gauss Jordan Elimination and a TI-83 calculator to get the answer once I've set it up and written the system of equations. So this first one I'm going to do says a basketball team sells tickets that cost $10, $20, or for VIP seats, $30. The team has sold 3,520 tickets overall. It has sold 127 more $20 tickets than $10 tickets. The total sales are $67,640. How many tickets of each kind were sold? So we really want to know how many $10 tickets, how many $20 tickets, and how many of those $30 VIP tickets were sold. So I'm going to let X, Y, and Z be our variables. X, the number of $10 tickets, Y, the number of 20, Z, the number of $30 tickets. I'm going to try to summarize a little of these. The $10 tickets, the X is $10, Y is $20 tickets, Z is $30 tickets. The team has sold 3,520 tickets altogether. That would be a total of the number of tickets. So here's one equation we have. We're going to try to get three equations. X plus Y plus Z equals $3,520. Another piece of information, I'll wait on this one for a second. The total sales are $67,640. Well, I'm going to put a line here, which really doesn't mean equals. It sort of does. Okay? If you sold all the tickets, or if they've sold this many tickets, they've got $67,640. So of each $10 ticket, they're getting $10 for us. For each one of these, they're getting $10. For each Y, for each of those, they're getting $20. How would we calculate this $67,640? Well, it's the cost per ticket times the number of tickets plus the cost per ticket times the number of tickets plus the cost per tickets. It's $30 per ticket for the VIP times the number of tickets. So there's a second equation. It's this statement right here that sometimes gives students trouble because they might want to. It has sold 127 more $20 tickets than $10 tickets. So it sold 127 more. It sold $127 more $20 tickets than $10 tickets. I think I said that wrong. 127 more $20 tickets than $10 tickets. That means that if you take the number of $10 tickets and add 127, you'll get the number of $20 tickets. I'm saying, okay, the number of $20 tickets is the number of $10 tickets plus 127. Do y'all agree with that statement? You see how I'm getting it here. What did they sell more of? They sold more $20 tickets. So the number of $20 tickets is the number of $10 tickets plus 127. If you think of it like this, if you knew that they sold 100 $10 tickets and you were told they've sold 127 more $20 tickets than $10 tickets, wouldn't you say, okay, then the $20 tickets would be 127 plus 100? The number of $20 tickets is equal to the number of $10 tickets plus 127. Now we need to get this written with the X and Y on the same side. So here's how I'm writing that third equation. Negative x plus y equals 127. And now I'm going to punch this in. Ooh, y'all can see this. Using a TI-83 calculator. See if I can lift this up a little. Okay. Let me make sure it's sort of focusing. That's just the machine focusing. Okay, so let's see. In order to use the calculator, you're going to punch in this matrix. 1, 1, 1, 35, 20. Then 10, 20, 30, 67, 6, 40. Negative 1, 1. There's no z. 127. So there's the matrix I need to punch in. Not sure how good this is going to show up there. To enter a matrix on this calculator, I'll say matrix, scan over to edit, enter, and I put in the size of this matrix. The matrix I'm looking at is a 3 by 4. 3 by 4. 3 rows, 4 columns. And let me see. I'm going to punch in that matrix that I wrote. Let's see. Can y'all see that? Sort of bad glare. So 3 by 4. 1, enter, 1, enter, 1, enter, 35, 20, enter. Then the next one, 10, enter, 20, enter, 30, enter, 67, 6, 40, enter. Negative 1, enter 1, enter 0, enter 127, enter. Ooh. So I punched in those numbers. And now I'm going to say second quit to get out of that. Matrix. Now I'm going to do some math on that matrix. So I go over to where it says math. And I'm going to either scan down or scan up until I see the button RREF. Reduced row echelon form. I think it's faster if we go up. Right there, reduced row echelon form. Enter. Now I need to tell it which matrix to use. Well, you might be thinking, well, it should know it's the only matrix we have there. Well, no. So it's matrix A. And enter. And let's look. Oh, can you see this? Oh gosh. Let me see. Ah. Y'all see those numbers? It's a bit of a glare, isn't it? 1223, that would be X. 1350Y, 947Z. Okay, so 1223 is X. Y is 1350. Z is 947. Now, let me just get the little thing and write the answers there in the box. Any questions? So, the number of $10 tickets. Ooh, wait. The number of $10 tickets, 1,223. The number of $20 tickets that were sold, 1,350. Notice, if you add 127 to 1,223, you get 1,350. They sold 127 more $20 tickets than $10 tickets. And the VIP, well, it's 947. Okay? Let's see now. These other ones, I'm doing this one, and then I'm going to do this one here, number 17, just because I haven't done that, an example of this yet. 16, this one here, I've already done this in example. So being able to punch this stuff in here is a very nice way of doing it. You got to use the matrix key and the RREF key under math. Okay? Let's see. Number 17 is actually two different problems. So let me lift this up. Okay, we're going to do 17A first. An investment firm recommends that clients invest in bonds rated at AAA, A, and B. The average yield on the AAA bonds is 4%, on the A bonds is 6%, and on the B bonds is 11%. The client wants to invest as much or twice as much in B bonds, as in AAA bonds as in B bonds. So he wants more money put into the secure AAA bonds versus the high yield risky B bonds. How much should be invested in each type of bond under the given circumstances? A, the total investment is $9,000 and the investor wants a return of $560 on these investments. So this is number 17. Okay. We need to know how much in AAA, how much in A, how much in B. To get part B, they're just changing some of the number values. So X, Y, and Z are our unknowns. And this is the amount invested in AAA, A, B. Now, we're given their returns. So here's another column, the return column. 4% or yield, whatever you want to call it. 4% for the AAA, 6% for the A, 11% for the B. Now here we're told that the total investment is $9,000, so that would be a column, right, or a sum right there. The amount invested in AAA plus A plus B should be $9,000. Here's a column or return. The annual return was $560, so that's sort of a sum there. Now there's one of these tricky statements. The client wants to invest twice as much in AAA bonds as in B bonds. So here's that statement. Invest twice as much in AAA as B bonds. Just like on number 15, if you think to yourself, which one's getting more? Well, if they're investing twice as much in AAA, that means AAA is going to be bigger than the B bonds. In fact, AAA is 2 times the amount invested in B bonds. Always think, what's the bigger one? Just like over on the other one, we thought, what was the bigger one, and added 127 to the other one. Okay? They want twice as much money in AAA as in B. So you take the amount of B bonds, multiply it by 2. For instance, if they only put $500 in B bonds, then they're putting $1,000 in AAA bonds. So the equations look like this. X plus Y plus Z equals 9,000. 0.04x plus 0.06y plus 0.11z equals 560. Now this equation here should have the x and y on the same side. So I'm going to move that. We'll write it as x minus 2z equals 0. You might want to remember there's a 1 there. So what will the matrix look like? I'm going to go ahead and write it down because I know it's sometimes hard to see. Not sometimes. It can be hard to see that calculator when I'm punching it in. So, and 1, there's no y, negative 2, 0. So this is the matrix right here that I'm going to try to punch into my calculator. Ooh, I'm still showing what I was using on the other thing, so let me clear that. I'll go to matrix, and I'll go ahead and edit that first one. Edit. It's still a 3 by 4. So here go the numbers. 1, 1, 1, 9,000. 0.04, 0.06, 0.11, 560. 1, 0, negative 2, 0. So I punched in all those numbers. Second quit, matrix, math, and what key do we go to? The RREF, matrix. Now if you had used a different one other than matrix A, you'd have to scan down and so forth. But I'm using matrix A. Ooh. Enter, and ooh, can y'all see that? I know it's hard. 4,000, 3,000, 2,000. So the amount of money they invested in AAA, that's the most secure, but the lowest rate of return, because it is the most secure. By that I mean most likely you're not going to lose your money. Fourth is twice the amount in the risky B bonds. Okay, so the answer here would be 4,000, 3,000, and 2,000. And we've only done part A, and you might think, oh no, but actually I think that we're almost finished, because the only thing that you do to do part B, all you're going to do is change the 9,000 to 2,600. So this 9,000 becomes 26,000, and the return changes from 560 to 1620. So all we got to do is change this 9,000 to 26,000, and this 560, change it to 1620. That'll be a good opportunity for you to practice with your calculator. You see, go matrix, and let's edit that matrix A. So I'm going to that same matrix and saying edit. It's still a 3 by 4, and you scan through, either hitting enter or the arrow. I'm changing the 9,000 to 26,000. Okay, and then I'm going to say just down arrow, change that 560 to 1620. Okay, enter. So I've done that. I can say second quit. Oh, let me clear that off. And now matrix, math, scan up till you get to the RREF, matrix, I'm still using A, enter, enter, So now the answers are 12,000, 8,000, and 6,000. So the amount of money invested in the AAA is 12,000, which is twice as much as in the B. The amount of money invested in the A bonds is 8,000. And I know it's hard to see with this glare, but hopefully you can get your calculator and practice with it. Okay? So 12,000, 8,000, and 6,000. Okay? Well, I think I've done if you've watched through all the videos, I've done a lot of these applications of Gauss Jordan, a lot of these Gauss Jordan problems. Hopefully you've worked on them, and we'll be discussing something different the next time. So thank you for listening and watching. Bye-bye.